So you've got access to the cover sheet, so you won't need to read through the instructions. This is the cover sheet with all the instructions. Everything that's going to be on, this is word for word, this is what will be on that first page. And the last page where you enter your answers will be right here, so you'll just have to circle them. Again, I encourage you as you work through the problems to circle the answer you choose and then go back to the answer key maybe at the end or sometime, but that's what I'm going to use is just that last page. So at least have those circled, okay? And then there'll be 2 pages just before this at the end where this big open, there's a question at the top, open page that says, show your work. Just show your work on those 2. So those are basically be the 3 pages I'll look at. However, any work that you do that's recorded on the other ones is evidence of understanding, so we can keep that for discussion afterwards. Any questions on the format for the exam? What are you allowed to use on the exam?
We need that lockdown browser thing, right?
No, you won't have your computers open at all. It's paper and pencil. So yeah, so paper and pencil, don't need lockdown browsers, nothing. Don't even, in fact, all electronics should probably be just tucked away, leave it in your bag. You can have a calculator, right? That's the one electronic thing that you should have. I would highly encourage it, as you're going to see some of the ones we go through, that's really the only way to do it, or one of the main ways to do it. The first 8 questions are multiple choice. So as long as you recognize the right answer, circle it. Show no work, that doesn't matter. You circled an answer if you get the correct answer circled. So there is a little bit of good luck involved, I guess. But also be careful, just with all multiple choice tests, and this one's no different. You'll look through and you'll find 2 answers that are very close to each other. It is probably going to be one of them, but making sure, even if you know the right answer, that you circle the right answer is important. Because the one that's close is just as wrong as the ones that are far away. Okay, there are a few, there's an E, so there is some that are said none of the above type thing. But we'll go through and do that. Then this document I got out of Canvas. I've got it posted there under, what do they call it, Exam Prep 1 or something. So it's in there, and then this is the review that we're going to work from. I've had a few questions emailed to me. I've got those set, ready to go. If we have additional ones, we'll go through those. I do have office hours right after this, but my office is not this big. So, but I don't want, anyone who wants to come is welcome to come. And we'll work through it. I've got class at 6, so we'll keep working through things. If anyone's interested, if we need some more time, I do have time. I finish teaching a class at 2 o'clock tomorrow on Tuesday over in Scottsdale. So I'm happy to swing back by campus about 2:30, set up a meeting. I'll find a room someplace. But we'll see how we do today. Office hours, if anyone wants it, if there's one person who wants it, we'll make it happen. But if you email me, then I just gotta know how much of a room I have to find. If I have 1 or 2 people, we'll just use my office. And I don't have anything after that, so it's kind of like we can go through it without being pressured to finish things. Although, you've got your schedules too. So tomorrow, about 2:30, is another opportunity where we can get together and review. Just don't keep me till 10 o'clock because I got an early morning Wednesday, and I'm doing my defense for my graduate degree, so I want to get my beauty sleep and look good and all that kind of stuff, but we'll be all good. Okay, so why don't we go ahead and start into the questions I have. I think we could probably get through them relatively quickly. Now this one, number 2, was asked, numerically or algebraically calculate this following limit. So we've got 2 options we can use. I haven't pre-worked these on purpose because then I would know how to do it, and then I'm just kind of telling you. I want you to know how to think through these. So one of the things I'm thinking is if I go algebraically, what approach can we just calculate the limit, first of all? No, because if you plug in 1 for x, you get a division by 0 in the denominator. So the next thing I was thinking, there's this little trick where we could multiply the top and bottom by 1 over x, right? And that oftentimes gets rid of the problem part, but what that's going to give us is, in the denominator, it'll give us 1 over x minus 1 over square root of x. And then when you plug that in, it's still 1 minus 1, you still got the 0 there. So I don't think that's going to happen. So my suggestion is let's try numerical approach. We want to see what's happening by one. And actually, this would be the way I would do every one that asked me to find a limit. I'd graph it first just to see what it's looking like around there, because that's going to give us a big indication. So for today, I'm going to, well, decimals would be easier to kind of navigate. You're going to need to be using these on the exams, so I'll use it here as well. I'll leave some of the stuff, like when you come into the exam, if you've got that set up with stuff like this formula that we did in class, you're welcome to leave those there. I have no problem with that. So in y1, I'm going to put this equation of 5 minus 5x. Of course, I'm recording this, but they don't get to see this part, but we'll see what's needed. Again, I'm committed to getting everybody what they need. What do I need? Square root, second square root of x. Get outside there, go with that. And then I'm going to go to the graph. I'm going to go to a zoom standard, just because I don't know what my last window was. Let's see what we see. And we're trying to figure out what's happening as x goes towards 1. I see this little line up at the top, so I'm going to go to my window and make my y max maybe 25. I think we'll do it. See more of the graph up there. So does it look like a limit's going to exist at when x is equal to 1? Does it look like if we go to where x equals 1, kind of go, which would be about there, that the left side and the right side are going to the same point? Yeah, it does. Now I can use my trace. Let's see. Trace. It's not showing up yet. Where am I? Oh. I don't know why my x value is like at 200, but okay, we won't do that. Numerically is kind of go to the table anyway, and we see that at 1 it's an error, at 0 it's 5, 2 it's 12. So we need to figure out what's happening as we get close to 1. Let me just show you, see, how do I do this? The table, if I go to table set, what I want to do is I want the independent variable, instead of being auto, I want it to be ask. Then I can enter any values I want as I sneak up on it. So I'm going to change that to ask. Now when I go back to the table, there's no values here, but I'm thinking I want to get close to 1 from both sides. So I might look at 0.9, 0.99, oops. 0.999. What do you see happening? Getting close to 10. So I would think at this point I would just say the limit's 10. But let's see what happens on the other side. So just a little bit bigger than 1. So 1.001, right? 1.00 or just 0.1, and maybe 1.1. And we see the same thing. Just on the other side of 1, it was 10.002. So I would say at 1, my prediction is good. That's all we got to do. We did it numerically. Algebraically is going to be a mess. And one of the things I've learned, like the only way I got through calculus was I had a 3-question test, and I didn't study for it like I should. I'm a freshman, right? Yes.
So if it's going to take all the tests, like, do you have to show any type of work?
No, not for the multiple choice. Now, if it asks this, because it said you could do it numerically, what you would do to show your work is just copy the table. That's work. Yeah. And it says you could do it numerically. This is numerical. So back to my story. 3-question calculus test. I didn't study. Thought I could just ace it anyway. Got to the first page, saw there was 2 questions. I said, I don't know how to do these, so I went to the 3rd page. Oh, this is easy. I did it, and I saw everyone else was really struggling. And another guy did the same thing as I did because he didn't study either. We were the only ones who got any points on that exam because 3 was a very easy question. 1 and 2 were almost impossible. In fact, he threw them out. Unfortunately, he also threw out the scores, but 2 of us got some points because we went to 3 because we didn't study. Everyone else got stuck on 1 and 2 and never got to 3. So the idea is, if you're doing a lot of work, remember there's 10 questions on here. It's designed to be done in 50 minutes. It's not designed to take a lot of time for any of them. And so use the easier methods. Okay. And for the multiple choice, you don't actually have to show work. It's not a requirement. You just have to circle the answer. If it's right, it's right. Showing work can help if you circle a wrong answer. It's something we could go back and discuss later. But again, when I go through the first grading, I'm really just, for all of these to get them in, I'm just going to look at that last page, see what answers you've got circled there, score that way. After we hand them back, if you want to talk about things, we can take a look at the work and we'll work things out. Because again, the biggest thing is building understanding. Okay, so I'll try to keep moving because I know you probably want to do this. So this last one is 10, was another question asked. Now this one just says specifically to do algebraically. But again, what I would do is maybe take a look at it. Again, it's not looking when x goes to infinity, which I thought would actually be a fairly easy one, right? Because as x goes to infinity, the bottom is much bigger, it's going to go to 0, right? But that's not the question, it's what's happening in here at 10. But again, we could, again, just to demonstrate, I will go ahead, even though they ask for it algebraically, let's go ahead and x minus 10. Let's go ahead and do this graph it to kind of give us an indication of what it should be. Minus 10,000 or 1,000. 1, 2, 3. And since we're looking for when x goes to 10 on my window, I've got to make sure I can see past that, so we'll go to x equals 15, and we should be okay. You know, I might have to zoom out or something. Let's see. X minus 10 should be, well, when you plug in 10, you get 0 in the numerator. Actually, can you see anything? I see a blue line right along the x-axis, so actually for this one, I probably need the y. I need to zoom in on the y, so I'm going to go from -1 to +1. So the y-axis has zoomed way in, and I start to see something, and I see sort of a little S-curve. But what's missing here at 10? Do you see an asymptote? An asymptote, we would be sort of forced. I don't see an asymptote. So I'm going to say there's probably a limit here. It's probably right close to the x-axis, so we're probably going to be able to do it. So what would be the method that we would use here? The one I was going to use on the other one, if I sort of divide everything by and again, I have, whatever I do to the top, I have to do to the bottom. So I think this one I would divide by x to the third, the highest degree, because then it'll, again, if I plug in, I always want to check, 10 to the third is 1,000, so that's why I get 0. So I'm going to multiply by 1 over x to the third in the bottom, and 1, oh, thank you. See, that's the thing I forget about. Okay, now we're okay. But, okay, we're over here. 1 over, let's see, where are we? X to the third, okay? And again, that's going to distribute to each of these terms. So what we end up with now is the limit as x goes to 10 of x over x cubed, which is going to be 1 over x squared, right? Minus 10 over x cubed. And then x cubed over x cubed minus 1,000 over x cubed. I'm not sure that, again, this is, I think it might not be the way we're going to be able to go. In the numerator, I get 1 over x squared minus 10 over x to the third. I get 1 minus, and again, I'm going to still get 1 minus 1 in the denominator, right? Multiply by the conjugate. That's another option. The other thing is, again, and I've looked at the ones that you have to, fill in or essay type questions. They're pretty straightforward, so you'll be okay. When you have multiple choice, what else can you do? You've got the answers, right? You could kind of try to plug them in to see if they worked. So again, with multiple choice, it's slightly different. You're trying to choose which one is the right answer. You know you've got the right answer. Or one of the answers is none of the above, so you could try them all. If none of them work, then you've got that as an option. Let's see, why isn't this isn't going to work, is it? If we multiply by a conjugate, we get to the 6th, we're going to have the same problem actually down here. X cubed minus 1,000, so that's a difference of cubes. Most of us don't remember how to factor cubes, me included, but there is a factoring for cubes, and then it's going to factor out the x minus 10. So thank you. Let's come here. So this is sort of a hint. Yeah, if this is going to work, factoring is probably the only way it's going to work. So we've got x minus 10. And a difference of cubes, as I remember, is going to be x minus 10, and then what's going to be left over? Okay, slow down on that. It's x squared plus 10x plus 100, right? So, and again, you could probably get it just noting that it's probably got to be an x minus 10, so if that cancels out, then we're going to be okay. That is going to cancel out. And again, I looked at the graph, I said, there's got to be a limit here. And so this is going to become the limit as x goes to 10 of 1 over x squared plus 10x plus 100. That's not going to become 0 when I plug in 10, and so I can just plug in 10. Okay? Good call. See, we got to. So this becomes 10 squared plus 10 times 10 plus 100, and I think that's going to be 100 plus 100 plus 100, so that's 1 over 300, and as my intuition told me, it's going to be a very small number, close to 0. Did I get that right?
Yeah.
No.
Okay.
So, and again, the multiple choice might be something like this, but yeah, I wouldn't expect anyone to remember how to factor, because I can't remember how to factor a cube. I remember that there is a factoring, but I didn't go there until someone suggested it. But thank you. Okay. So yes, the review is intended to be harder than the exam itself. But know how to do these kind of things. So then the next question was 13, and I'm thinking this is going to be pretty much the same type of thing. What you'd have to check is if you plug in -9, do you get a 0 in the denominator? And I'm going to assume that that's probably what happens, because this is going to be negative, right? Certainly in the numerator, we're going to get a 0, that's okay. But if we get a 0 in the denominator, so again, I would graph it to see if this limit exists. So let's go back. And I think this one also will have a solution by factoring, but before we go there, and we'll take and we're looking at when x goes towards -9, so we're looking to the left side. Don't see anything over there, so let's come to our window. Let's go to -15. Oh, my y, okay, y minimum, y maximum. Let's go to -20 and +20. Okay. So we see that when x is -9, we see sort of continuity, at least it looks like it. So I'm going to say that the limit exists. We don't have an asymptote. But also the other thing to look at is go to the table and plug in 9. Well, we already did that. Oh, sorry, plug in -9, right? Because if it gives us an error, which is unfortunate. If it gave us a value, it would be done. Does want us to go algebraically, but we could also do the same thing of looking at the left and the right. So I would do maybe -9.1, and I see it's coming close to 1.27, and then maybe -8.9, right? So we can see it's getting close to about 1.3-ish. So let's go ahead and do this. Factoring the top, we'll get x minus 9 over x plus 9. And hopefully in the bottom, well, we're going to both turn. So when I look here, it's going to factor, since this is going to tell us that both factors have the same sign, and since this is a plus, both are going to be positive. So it looks like the x plus 9 will cancel out, which is good, because if x plus 9 cancels out, then I can just evaluate. Oh, thank you. Like even after all this time, I go on Zoom and forget to turn off the mute, right? So yeah, this is like muting. You can't see. Okay. So we got this top factors, the bottom. Let's see. Since I've got a 2x, it's going to be 2x and x. Because of this top, the 36 I'm probably going to be able to use 9 times 4. 4 times 2 is 8. 8 plus 9 is only 17, so I'm going to say I probably need the 9 here and the 4 here. Both signs are the same, and I can see they're both going to be positive. Let's see if this works. 9 times 2 is 18. 18 plus 4 is 22. That's the correct factoring. And what I'm able to do now is cancel out the 9s. And actually, I can go ahead, probably, just plug in -9 because it doesn't give me something that's undefined. So now I've done it algebraically. I can evaluate it. -9 minus 9 over 2 times -9 plus 4. This is going to have the same limit as, or the original function will have the same limit as this being evaluated. So I get -18. This is -18 plus 4. So it's going to be -18 divided by -14. Okay. Which is going to be 18 over 14. Let's see. 2 goes into both of that, so that's going to be 9 over 7. Oops, 9 over 7. And I think if you plug that in, you'll get the decimal equivalent of about 9 divided by 7. Yeah, it's 1.285. Sure. So that good on that one? Okay. What I did is I knew from the numerator, I just remembered that x cubed minus 10, or if I have a difference of cubes, there's a formula for calculating these. Now, I'll be honest, I got some help from over here. I knew that x minus 10 would be part of it. What I would have had to do is, if I was actually on my own in doing this, I would have had to play with this a little bit. I remember, and this is something you might want to go ahead and review. I mean, it doesn't hurt. Hopefully it's not there on the exam. I don't remember a cubic being there, but there is a formula for cubics that a squared minus b squared, that it will factor into a minus, cubed. They're cubes, difference of a cubed minus b cubed, factors into a minus b times a squared. And the thing is remembering these signs in between. When it's a difference of cubes, it's going to be plus b squared, and I think this middle term is 3ab. Is that right, or is it 2ab? Or it's just ab? Okay, but that's a formula that you'd have to have. So maybe do a quick, brief review of that. Things like that. Okay, and then I have these. I got these two and 41. Those were the only questions. I'm throwing this one in because there was a number of questions on that. Let's see, where are we at time? Okay, we got about 20 minutes, so let me move through these. The other thing you can do, if maybe tomorrow you're busy or something, if you'll email me questions Tuesday night, I can probably, or maybe even tonight, but I got classes tonight till 8, but I can do videos and post them, video solutions. We can do that. Okay, so show that there is a solution for the equation between x minus 2 and x. Now with this one, again, it's just getting into theories. There was a theorem we had, an intermediate value theorem. So what we have to do is we evaluate it at -2 and at 0, and we're going to show that this solution, right, has 0. One of them is going to be negative, one of them is going to be positive, which that guarantees us that somewhere between those two x values, we will cross the x-axis. We will have a y equals 0 solution. That's what this is dependent upon. So we evaluate it at -2. Plug in -2 cubed minus 0.5 times -2 squared plus 1.5. And now we're not looking for this to be 0, but we're looking whatever value it is, that when we put 0 in, which maybe I should have done first, it's going to be easier, that we got two different values. So -2 squared or cubed is -8. -2 squared is 4. 4 times 0.5 is going to give us -2, right? 4 divided by 2. You think of 0.5 as a half. I think I got that right. And then we plus 1.5. We can see this is going to be -10, so -8.5 is its output value. So what we're banking on is at -2, we've got a point of -8.5. We need to see what is the y value when x is equal to 0. That's going to be easier. Plug in 0, 0. It's going to be 1.5. So when x is 0, we're at 1.5. We are guaranteed, because this is continuous, okay, it's a polynomial, it's continuous, that the only way to get from point A to point B is to somewhere. We can mess around, but we got to cross the x-axis someplace. That's all we had to prove. There is a place where y will equal 0, because this is called the intermediate value theorem. And again, we're not going to test you on that knowledge, but there might be something where you apply it, where you need to apply the intermediate value theorem. At least there wasn't here. So we're okay with that? There's another one called the squeeze theorem, right? And that just says that if a function is always between two other functions, And the limit of those two functions, when we get there, it will squeeze the limit to exist. So we had a few problems on that, but I don't think too much. Okay, so this one is a good one because it's a piecewise function deal. And we've got this breaking place, little r. The thing you've got to see here is little r is a variable. Big R is standing for a constant, some constant. We don't know what it is, but it's some constant number. And at big R, there's a break in the two functions. So both of the functions we have there are rational functions, which are, by definition, continuous. So the only place we have to test is that place where the piecewise function breaks into pieces. So what we're going to do is we're going to take the top one, we're going to plug in big R. We're going to do the same thing with the other function. We're going to plug in big R and see if they are the same point or the same value. If they are, then we're continuous. If they're not, then we're not. So 2.8R over, oh wait, I just said what we're plugging in is we're plugging in big R for little r. 2.8 big R over r to the 6th. And what we're checking is that equal to the second one, 2.8 big R over big R to the 4th. So we can simplify. This is going to be this side. This r cancels. We get 2.8 r to the 5th. Does that equal 2.8? Again, this cancels down, so that's going to be a third, r to the 3rd. Not always, but there are a couple places that could happen. Maybe one place, maybe two. When x is 1, if r were 1, right, then it could happen. If r were -1, since they're both odd, it would also, they would be equal, but that's the only place. So this, it's not continuous. Unless big R is equal to -1 or 1. The reason it couldn't be 0 is then it would we'd get division by 0. But I know on the solution they had that, but I just looked real briefly at it. They said it could be 1 or -1 or possibly 0. But the only way that would happen is you had to keep it out of the you'd have to keep it out of the denominator. So but anyway, this question really, you won't find this sort of abstract question. It would be more specific. What you're learning here is if you've got piecewise functions and we need to check for continuity, you'll be given numbers, but just check the breakpoints. If there's 3 different breakpoints, check each of those breakpoints that they're connected. Okay, that's basically what you'll be asked to do. You won't be asked to do this on the test, and it won't be that complicated. But that's, with piecewise functions, look at where the pieces change from one to the other piece. Okay. And I imagine with this one that the question might have been about the normal line. We haven't talked about normal lines, have we? Not yet. We'll get to them. Normal lines are perpendicular to the tangent line. So basically for this one, once you find the tangent line, you flip the slope, make it the opposite, and then you can find the normal line. But I didn't see what exactly someone asked about this. So, but finding the tangent line, we could do that. Again, we could do it with the calculator. So if this was multiple choice, do you remember how to find the tangent line with the calculator? Anyone want to see that? Okay, so we'll do that because that can be done relatively easily. So again, we're going to graph the function. Let's clear this one out. So there, okay. So we graph 3 plus 6x raised to the 2nd power. I'm going to do a zoom standard because I think it'll fit okay. we want to find the tangent at the point 225. So that tells us our y value is way up there. So I'm going to fix my window a little bit. I'm going to go with y max at, let's just go to 500. And I should be able to see more going on. And then I use the draw feature, which is a shifted program. So second program, I'm going to draw a tangent, and I'm going to draw it at x equals 2. So I put in 2, enter. It will give me the tangent line, and then it will also give me the equation of the tangent line. We're done. It's right there. Y equals 100x minus 135. Okay. And again, that's the way I would have you do it. The way to go about it with this is, I guess at this point by 41, we probably can take the quick derivatives, right? But what we'd have to do is FOIL it out. So 3 plus 6x, 3 plus 6x. FOIL it out, we're going to get 9. 3 times 6 is 18. 18 twice is 36x. And then 6x times 6x is going to be plus 36x squared. We need its derivative, right? So this is y. So the derivative of y, derivative of 9 is 0. Derivative of 36x is 36. Remember, this is to the first power. 1 minus 1 is 0. And then this one is going to be 2 times 36, 72x. So that's our function for the slope of the tangent line, or at any point. We want to find out at 2. So we plug in 2, and we find our slope at 2 is going to be 36 plus 72 times 2. That's 144 plus 36, 50, 180. Did I get that right? And that's what the calculator's telling us, so that's good. And so I've got my tangent line is going to be y equals 180x plus b. I take the x and y coordinate, plug it in, so I get my y-intercept. So I get 225 equals 180 times 2 plus b. Solve that. 180 is going to be 360. And again, we'd subtract that from both sides. So we're going to get negative 75, what's it, 130. I'll cheat here. Oh, yeah, 135. Okay. So negative 135. That's what our b is. So we could do it by hand. We could do it with the calculator. Okay. And so y equals 180x minus 135. Let's choose that one. The normal line is going to be, again, it would just have a slope of 1 over 180, and it would be negative. And again, that puts it at 90 degrees. And then you'd have to find the y-intercept by, again, plugging in that point and doing it. We're not going to ask you about the normal line because we haven't done anything with it yet. You'll do that a lot in the next calc class. I taught that before, and when you get into 3 dimensions, that normal vector is kind of important. It helps you a lot. So just remember that. You get the tangent in this class. Next class, you'll be doing more and more with the normal. Okay. So then we're down to this one. And again, this one, I guess, what time is it? Got just a couple minutes. This one, I've seen a lot of people who actually have right answers and it's marking it wrong. The reason is, the only way I can see to get these answers is estimating from the graph. The answers they have in the solutions are like to 5 decimal places. There's no way, unless you had the function, there's no way you could get that. So it's marking wrong. What I've done is as long as you've gotten 90% on the homework, you're getting full points. So that's on everything. Also, I got a couple emails. I did update scores, but they're not like final. It's just to kind of, this is where you're at today. Yeah. Chapter 2 is open until tomorrow. The reason I have it closing tomorrow is that because when it closes, it will show you the answers, it will show you the solutions. So if you're still stuck by that time, then Wednesday morning before the exam, you can go through and you can see solutions, you can see, actually, I wasn't supposed to do this, but you actually can see them now if you need to. There's try another. If you use that, I was supposed to wait till they close to do that, but I said, I want you to prepare. Click on try another. It gives you a different version, but it will show you the solution. So you'll see how they solved it, and then you could go back and do yours. Because I have no problem with you getting all the homework points, because those are still percentage-wise a small amount compared to doing well on the exam. So actually, you can get the solutions. Just try another. It opens it up in another window and shows you a different problem, but shows you how to solve it. And it shows you the answers. And a lot of times that's enough to go back and then work the one you're on. Because again, I'm more concerned with you understanding versus getting a few extra points on a homework because you got some help. It's a good resource. So I'll do this also next time. But then they will close Tuesday night because I don't want you up till 3 in the morning working on homework. If you want to stay up till 3 in the morning and study, that's okay. But homework, let's try to get that finished up and we'll work through it. So anyway, with this one, they're asking to estimate t when t equals 10. I've got a bigger version down here, maybe too big. So the only way I can say, so if you've got this wrong, we'll do this. And if it's marking things wrong and more often, I don't think it would affect more than 90%, but if, I'll get you all the points. So if there's something doesn't seem fair, just contact me, we'll make it till it's fair. 10 is 5, because these are each by 5, so what they're asking for is this point right here, right? 5, 10. And so we just got to read off what is this line, and this is going up by 10, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and 10, 20, 30. So we could estimate that t is 130 when x, or whatever this little one is, maybe it was little t, equals 10. They want you to get the rate of change, right, on this one, dt, d big T, the little t, and what that's going to be is the slope of the tangent line when t equals 10. So they want you to get the slope of the tangent line. Again, the only way I can really see to do that is to find another point on this tangent line, and there's not a really good point that this one's kind of close, looks like it's crossing there, so I would maybe use this as a secondary point, calculate the slope, and that's what I would do. But my answer is probably going to be off enough that it doesn't mark it right. And then you go, because then you use that to find the next one. And again, I couldn't match the answers. I did get close enough because it's got some kind of thing in there that will accept close enough. And but it was just like, I don't know what they're doing to get the answers that they've got except cheating. They've got the formula and they do it. Yes?
I think it wanted you to look up the relation for the law cooling, and then you could reverse.
That's not, yeah. Why would you? I mean, you can't do that on a test, can you? Well, let me get my reference point. Okay, so that was, what do they say? See, no, that's my problem. I don't always read the question. I see the graph. I see what they want. That's all I stop. According to Newton's law of cooling, okay, yeah, maybe you could look it up, the rate of change of object's temperature is proportional to the difference between the temperature of the object and that of the surrounding medium. Accompanying figure shows the graph of the temperature T versus T in time of cup of coffee cooling down from 200 degrees Fahrenheit that is allowed to cool to room temperature. I mean, they provide some things here, but they're referring to this graph. That's the only way I can see to do it. So anyway, if it's causing you headaches or anything, that's the only way really I see to do it. They gave us a graph. They gave us the full function of what we were doing. We could probably get there, but it's not on the test either, so I'll put it that way. So where are we? We got about 5 minutes. What else? Do all the rest in 5 minutes? No, I can't do that. Okay, so remember, the answers are here. So you can kind of go back and forth. The exam itself is only 10 questions. 8 of them are multiple choice, so you've got to be able to identify the right answer. Also, I was asked about graphing piecewise functions. You did? Okay. So I'll put a link anyway. It can be done with the TI calculator. It's just a little complicated, but I'll get to that video. Yes. Yes.
So actually, I wanted to ask that in the exam, it's 64% MCQs, right?
Is that?
It's written 64% is multiple choice questions.
8 out of 10, yeah.
Yeah. So
Great.
2 questions are we have to do it in steps.
Yes.
So can I use if I know some other theorems, can I use it? Or I have to do it your way?
You just have to show mathematically how to do it.
I can use anything.
Yes.
If you haven't taught it. Thanks.
Yesterday, on Friday, we had a talk during office hours. I had some questions to ask.
Okay. And I'll be going to office hours right after this.
So I will come with you.
Perfect.
Question. You know why it says like out of 20? We have to 20
Test 1 review. Those don't have to be turned in. No, those are just for your review. They must have put those in by default. Thank you.
So I've taken a calculus class before. So I
Okay.
have like a law like L'Hopital's law. Would I be allowed to use it, or would that be cheating? Like a law like L'Hopital's law.
We haven't used L'Hopital's rule here, but they don't allow any notes. So anything that we are going to use, and again, the only 2 real theorems we've used so far is the mean value and the squeeze.
So would I be able to use that on the test if I already know it?
Yeah, of course, yeah. Hi. Perfect. Yes. What's that?
Do you recommend the graphic or a scientific calculator?
Graphing calculators, definitely.
What time is it going to be like? 40?
On the Wednesdays class time, 2:30.
So that it is 3:30. And then we go home and upload it, or
No, I collect them and then I grade them.
so it's going to come whatever we learned and now the questions are going to come from there, right?
They come from the review. Well, the review goes over the same types of questions.
Where's your office hours at?
They're ECA 339. If you want to maybe just wait at the top, you can follow me because that's exactly where I go right there afterwards.
I'm not sure if this been brought to your attention yet, but like homework, the answers are released for like all of them. Oh yeah. This is paper pattern. 44 questions and 8 minutes.
Yes.
So
So
we have to
the-
solve that in 50 minutes.
Yes.
I'm also have a doubt that I don't have a graphic calculator, so I can just solve this without a graphic calculator, right?
Not necessarily. I mean, it's some of them. It might limit the ways you can do it, but if you can do the review without it, then that kind of shows you. But
If it's like similar type of problems, then I'll be able to do it. I can solve these without graphic. And also there's a problem where sine of 4x by 9x is given. So I know that limit when x is approaching to 0, sine of x by x is equals to 1. So I can